Oh, thank you so much. I'm going to talk today, and I'm going to try to actually go through my actual material relatively quickly, because I really would like to be able to leave some time for Q&A, and I hope that the stuff I have to talk about will promote some. Some of the things I'm very much interested in getting feedback from the audience about directions to go. The thing I'm going to talk about is a library that we have. Here, let me go through the first couple slides where I say that I'm that, and Continuum's great, and I carry advertising here, and run Anaconda and use our other stuff. And I did a bunch of things that Brian summarized as well. But this is what I'm going to talk about. We have a product that currently is part of our proprietary for our commercial customers called IOPro. This is just the description that's on the website. You can go to, Continuum IO, and I don't know the exact URL to that, but /doc/IOPro or something, and it'll tell you that it does this, that it's this library for speeding up access to big data sets. So that's great, and it's kind of cool, but of course it's proprietary, and part of this talk is to let everybody know that we're going to be opening up and releasing as free software this component, the part of, okay, you can install it today. If you do it today, it will install fine. Of course, you have to have Conda. But when you run it, it'll give you little nags about the fact you have a 30-day trial period. Hopefully, within 30 days, it'll have moved to open source anyway. And if it takes more than 30 days, sorry, but it will be in the near future. But the particular part, actually, that I want to release is this thing called TextAdapter. I'm primarily, in my job at Continuum, do training. So I go to the customer sites and teach scientists about learning Python and learning the scientific stack, NumPy and SciPy and Pandas and Matplotlib and Bokeh and Dask and things like that. And one of the trainings I did recently was about this commercial library we have for one of our customers that has bought it, about IOPro, and sort of in the course of doing that, I taught it. I got a good understanding for the first time of what this software does, and but I also found some bugs and rough edges in it, and decided that rather than document the bugs, I should just fix the bugs. So I think I'm now the official maintainer of this particular library, which is great. It does cool stuff, and hopefully I'll oversee, I'm pretty sure I will, this open sourcing of this part of it called TextAdapter. And this is a description that's more or less what's on the website too of what it does. But this TextAdapter part that I really want to get into the world in open source, it gives you a way to deal with textual data sources. So CSV, maybe JSON files, maybe fixed width or sort of funny formats, and do it in a way that's much faster than you would do without using this adapter, this library. But there's a bit of a trade-off here, which I think will be kind of obvious to people as I talk about it, is at a certain point, if you have a data source, there's lots and lots of things that are published as CSV files from public sources, from private sources, whatever. And maybe they're huge files. They're gigabytes of CSV or terabytes. And at a certain point, if this is data that you're working with all the time, you don't want to use our adapter and access it that way, because you want to put it into a proper database. Or maybe a key value store, or maybe a NoSQL, or maybe SQLite, or this is something that can speed it up a lot, and I'll show you some examples here, but it's not sort of the optimal permanent thing, and I don't want to oversell it in that way. On the other hand, I think that for data scientists, a lot of what we do is not really dealing with data on a permanent basis. I have some examples you'll see later that I get from the health insurance marketplace, some stuff that's government data that was released about all the things about, before and after the ACA and the consequences of, the kind of health insurance people have. So this is a cool data source, and it has lots of useful information. But maybe in your job, you just need to get a picture of what's going on with this data. And it's not something that you're going to, on a daily basis, keep running jobs against and, analyzing over and over in different ways. And it is sort of some work to put it into your permanent database setup and, define your schemas and whatever, provision the disk space or the servers or whatever it is that's necessary. So on the other hand, if you're just going to, read through it once and never do anything again, probably this is overkill too. So it's sort of the intermediate space. You're dealing with this data, and maybe you're going to access it tens of times, maybe hundreds of times, to get some picture of what's going on, and then maybe you're going to do some other exploration of another data set that, comes from the same place or somewhere else. And for that particular use, with very little overhead, I think TextAdapter can get you something very nice in several respects of having a more convenient API to this data, and particularly a much faster API to the data. And one of the key things it does, and I think maybe the most important, is, am I not loud enough? Okay, I feel booming. Test? Okay. Okay, that loud enough for people? So the thing we can do is we can create an index on the data. This slide just says that, but I want to show some examples of how it works. So maybe I have some data that could be on a local disk or on a sort of semi-local network drive, or it could be in the cloud. It could be on S3. Somewhere else we don't yet have the interfaces for, but I kind of hope once we open up we'll have interfaces for other cloud services. But anyway, S3 is hugely popular, and we have that now. So this is a fairly small file, and maybe it won't show things to the best effect, but here on S3 there is this data from the health insurance stuff called plan attributes that has 77,000 lines, and it's a 95 megabyte file. And okay, you could load that into memory. That's not absurd to do. But I just want to show you the API at this point, and I'll show you a little bit with some larger data. So we can just create this adapter object that accesses, with the key information and the bucket name and all the usual stuff in S3 access. But then when we open it, we're going to generate an index. Of course, we have to do a linear scan through the whole thing once to create the index. We're not going to magically find out where things are. But once we've created the index, things are going to go much, much faster. And the problem here, of course, is that with data that has fixed size records, it's really easy to do a calculated offset. With CSV data or JSON data or some other delimiter or other formats, it's not easy. You have no idea how long one row of CSV data is, and so therefore you have no idea how much you would jump for an offset. And even if you made a rough guess and tried to jump, approximately where you think it is, you have no way of knowing how many lines into it you are because you don't know all the lines that you skipped over. Maybe this is obvious to everybody what I'm saying, but our software does some stuff behind the scenes. So for example, this is what I ran on my computer, is I ran the little script to read the plans. I did it once, I did it again, and I go from taking 1 minute to taking 15 seconds. So 4 times speed up here. If this was a larger data source, it would be a larger speed up. But I'm still going to be somewhat limited because the way S3 works in particular has blocks of data. So you can't just read to an exact seek position, you still have to read a block. But if there were 100 times as many blocks, you're still just reading that particular block out of the data. So you're probably, if the data were 10 times as big, the first number would be 10 times as large, but the second would still be 15 seconds. So that could be a substantial win. When I say here that it's pretty good. But we can actually do even better, I think, on local file systems. I haven't benchmarked every permutation possible, but I have one here where I have some data. It's on my local file system. Again, it's from this health insurance marketplace set. And in this case, I'm actually putting it in a gzip file. So I compress it because I don't want to spend a lot of time storing it. And there's a nice property of a gzip algorithm where it regenerates the compression table periodically throughout it. So you're still not getting exact seek. You have to seek to the block where the new compression table starts, but you're skipping most things. And this is much bigger data. This is 13 million lines instead. It comes to 110 megabytes compressed, or 2 gigabytes if it were uncompressed of the raw data. So this is maybe not quite big data yet, but we're at least getting into medium-sized data. Maybe I should have, for the talk, tested against something that was bigger than this, and I think the effects would be more dramatic. But what we find here is, again, it's pretty much the same code that we saw on the previous slide. We're opening up, not the S3 text adapter, but the text adapter. That particular file, yes, it's compressed, it's a CSV file, and we're going to generate the index. And we're going to jump to a particular row, or actually a particular range of 5 rows in this case, but it could be a larger number. It's near the end. So I'm jumping to row 10 million through 5 more than that out of the 13 million rows. If I had just used the CSV module, I'd have to linear scan through everything to get there. If I had tried to import this into a pandas data frame, well, probably I have enough memory for this one, but if it were bigger, I might not have enough memory. But this will work on unlimited size data. And what we get there is quite a bit more win. It's about 20 times faster. And all I had to do was just wrap that adapter around it. And then what I can do is use a slicing syntax to pull off a collection of rows and get a NumPy array as a result. Optionally, you'll see in a second, I can make that a pandas data frame. But this is a way to look at chunks of the data at a time and put them in these familiar interfaces as NumPy arrays or as panda data frames and take advantage of this indexing to get to later parts of it very quickly. So you imagine, I repeatedly, for some reason, am interested in row 10 million or the region around there of the data, and I can do it quite quickly, repeatedly, once I've generated this index. And I'm not sure if it was evident in the S3 example, but the index I generated was on my local disk, even though the data continues to live out there in the cloud. So, I have local disk access for that, and it's a small file. It's, whatever, maybe kilobytes or something for the index file. And just to show something off, on my particular computer with the CPU and the number of cores and everything else I have, accessing the data near the end is actually faster than just the gunzip operation all by itself. So just decompressing takes more time than jumping to the row near the end. About a little over twice as long in this particular example. But in the stuff I showed you above, I actually cheated a little bit. But the way I cheated actually gets to some more features that we have, although it also gets to some things that I know I want to enhance about TextAdapter. One of the things TextAdapter does is it looks at the data you're reading at the particular slice or offset that you're looking at and tries to do some type inference about the data. And the type inference is much less smart than it should be. So it often makes the wrong guesses. And if it makes the wrong guesses, unfortunately, the failure mode is currently not that great either, but whatever, I filed an issue against it, I'm going to fix it. So you get tracebacks, basically, which are horribly ugly. You don't want to see those. But you can manually specify data types that you're reading. For what it's worth, if you were to take a huge slice, it would probably make a much better guess because you'd have seen representations of all the data within a particular column, and that would be kind of nicer. But in my example, I was just taking the 5 rows out of it. But there was a line above in the code that I showed you that had this, and I just imported what data types was from another module that I didn't show you. But this is what was in it. Something like this, is that after I got a few of these tracebacks and I took a look through what was going wrong, I decided to assign data types to particular fields. So column 0, that's a 4-byte floating point. And for the rest of the stuff, I just said, these are just the object data type. Completely generic, they're Python objects. That works. I mean, anything's going to be fine as a Python object, whatever you happen to read. I mean, it's going to be a string, basically. But it's not the absolute best, because you're probably going to want to do some computation and filtering and all the things you do in the analysis. So you probably want more specific data types. I mean, you see that in the column 0 here, where I've given it, floating point of a certain number of bytes. But this was a cheap way to do it by making a lot of stuff object type. But let's take a look at what we can do if we want to massage it a little bit. This rate is the big one. This is the one with 13 million rows. So the timing is maybe a little bit interesting. You can use, in the adapter object, the pandas style of indexing, where you present a list of different columns that you're interested in looking at. So this is going to pull row, I guess in this case it's row 9 million rather than 10 million. And I'm only interested in those columns whose headers are these several things listed, issuer ID and business year and so on. This particular, the other one I think had 140 some columns, and this one I think just has 40 some columns. But in any case, this is the syntax that is familiar to people who have worked with pandas or Xarray or other things that are kind of familiar as a way of accessing data framey kind of things. So it has some familiarity in the interface. And what we see in this somewhat naive approach to reading it, we very quickly, I mean here in 1/10 of a second, not even the 1 second that we saw reading the range, and most of the savings, some of it's because we're only reading 1 row as opposed to 5, but the other part of it is because we're only looking at some of the columns. So I think this is very reasonably fast. 1/10 of a second is not a huge delay in most of your processing. Obviously, if you're taking a much larger range of rows or more columns, then it'll slow down somewhat. But what we have as a result of doing this indexing, first into the collection of columns and then into a particular row, in this double indexing on the screen, is some values and then some data types that are associated with them. You see that the first one is just generic object data type, which is not great, and the others are unsigned integers 8-byte, which is the fallback if it sort of doesn't know too much, which means it was just empty or zeros in those particular location. That's okay. I mean, we pulled off the data quickly. We could process it as is right there, but actually that's not the best way to deal with the data. Once I look at it a little more closely, I know a little bit more about the kind of data that I encounter in those columns. So, for example, business year isn't a generic object. It's a year. It's 2008 or something like that, and that seems like it should fit perfectly fine in an unsigned 16-bit int to me. So why bother spending more memory on it once I've loaded it into the in-memory array? And column 16, you notice that I can use either the name or the numeric offset, which corresponds to the one that's called couple, is column 16. I want to be a 4-byte floating point number. So again, I do the same thing. In this case, I just pull off the second row, which the index doesn't matter at this point because it wouldn't take any real time to get there. And I get some other values, but you see that they're data typed in a more interesting and appropriate way, and in particular a way that uses less memory to hold each row. So if I were to not just read 1 row here, but read, say, the million rows I was interested in, I could probably now start to fit it in memory more conveniently with the smaller data types that are more appropriate. And I just mentioned in sort of the footnote that probably issuer ID doesn't really need 8 bytes. It could probably be some smaller number to store that number, but it'll just leave it as that for now. But there's some more we can do when we create these adapters. We can actually create an adapter that massages the data. as it comes into the adapter, or when it's, when we actually access it. So when I looked at this one that was the plan attributes, the one that was not so large, but it was over there on S3, I noticed something about the fields that were actually the ones that were failing. And I just said, these are generic objects. And I saw that they had these particular values for a couple of those field numbers. And they, create some ideas in my mind about what they probably mean as data types. I could, of course, look a little deeper and look at more than just the row where it was a failure and a variety of things to make sure that I'm really on the right track. But, to me, yes is probably either going to be yes in that field, or it's going to be no, or maybe it's going to be empty. But essentially, that looks like a representation of a Boolean value to me. And this other thing, $1667, well, that really looks like a floating point number, but it's not going to be parsed in the type inference as a floating point number because the $sign isn't, the signature of the initializer to float in, NumPy float or Python float. But, it should be easy to get the right thing out of that. And similarly with the percentage and the other things. So if I look at the way that the data looks as strings, I can probably massage it into my in-memory representation into something that's a bit better. And the way I do that is by creating one of these converter functions, or a couple of these converter functions in this case. So I've written a little function that I could reuse on many columns that's yes to Boolean, and it's just if the string is yes, and I decide the lowercase version of it to be a little bit more general. Oh, that code is broken. There's a bug there. That's sad. Anyway, it should be lowercase yes in the code. Pretend that I had typed my letters in the correct case. I could set a converter for that particular field of that function that as it was read into potentially a NumPy array or a pandas data frame, it would automatically massage it into a Boolean value in this case by doing that comparison. Or on column 63, here I'm giving the number rather than the name, I could do just a lambda function inline where I'm massaging it. And in this case, I'm taking off the percentage sign and dividing by 100 because it's something I expect to be a percentage. So then I want to set those field types to the particular things I'm interested in. So B for Boolean and F for 2-byte floating point. And I imagine if I had written the code right, once I get the result of those couple columns, number 43, which happens to be dental-only plan, and then, number 63 is issue or actual, and 43 is dental-only. Whatever. Again, I'm just showing the selection using either numbers or names. And I'm pulling off this row 70,000, which was, again, near the end of this particular file. And I had created the index. It's on my local disk. This is happening now, although there's no timing information here. So I get some values that are minimally represented as a Boolean and a short floating point. And I'm pretty sure that when I was trying to test this, this should show as a 1 rather than a 0 if my converter function had been correct. So that's a thing we can do to get our data into sort of cleaned up into this adapter object. Another way you can approach it is you can use regular expression patterns. So maybe you want to read in your data and, maybe it's kind of delimited, but there's things between the delimiters that are actually sort of different components of the data, or there's other things that are kind of, or maybe that's not really delimited at all, but it is line oriented. You can write a regular expression to pull out the parts of the data that are interesting line by line and present it in the same uniform interface that ultimately is to get some part of it into NumPy arrays in memory. So here's a way, I probably should have tried to put these on the same screen, but you can see it's a messy pattern. There's the $sign thing and the percentage sign thing, and then there's this date spelled out in a sort of ugly way that's not going to be easy to convert to a real datetime object. But this is the pattern. Oh, and by the way, that was actual NASDAQ published data. I mean, those are 2 lines of it, but I didn't make that up for the example. That's real world data. So what I'm looking for is the things that are in the regex groups. You see that some of the stuff is surrounded by these parentheses in the regular expression, and others isn't. And so the stuff that isn't in any of the groups, we're just throwing out. We're not interested in that data. We're discarding it. But the stuff that is in the groups, we're going to use as the data that we're reading in. So we read something that is 1 decimal digit, then we're going to read, and we're going to ignore the dot, and then we're going to read a couple decimal digits too. And then we're going to read a bunch of, and like here I just arbitrarily said 0-9 rather than \d. And 1 or more of those, and discard the percentage sign. And you see how it's broken up here. And the parser we're using here is not CSV, it's regex. And it's that particular regular expression. In my little thing I showed you, I don't have field name headers, so I'm not going to try to use those. And we're not going to bother inferring types. We're going to set them explicitly here in the next slide. In particular, we want those types to be, 2-byte integer, 2-byte unsigned integer. Anyway, there's several things for the several columns. And we want the names of those columns to be dollars, cents, percentage, and month. We're discarding some of the stuff that was in the line, but we're interested in others of it. And then when we, in this case, do an empty slice into the whole thing, because it's actually small data and I can do that. But I sort of don't, this feels like an attractive nuisance. And unfortunately, it's actually in some of the official documentation currently of IOPro, where it says empty slice to show examples. But if you're actually dealing with the kind of data sizes where it matters to be using TextAdapter or IOPro, then taking the empty slice is a bad idea because it's too big for memory, what you're reading. So I'm not sure what API would avoid that. Maybe issue a warning when you do it, or I don't know. But you see the data we're pulling off here is some integer dollars and integer cents, and a percentage sign as a floating point, and I probably should have divided that by 100, but anyway, and a month as a string that's up to 10 characters. So we're massaging data as we're reading it in, and what we're pulling off is data frames. Or what we're pulling off sort of immediately is arrays, but you can convert those into data frames. Now you could do this where you take that empty slice and you just say make the whole thing a data frame, but again, that's sort of crazy because the data is too big, and that's why we're using this library to fit in memory. But this is a better way to write it in the second line. It's not as a string, but the actual thing is just create the NumPy array object that is a certain slice of a reasonable amount of the data. It could be more than 2, but 1,000,000, not a billion, sort of thing, and convert that into a data frame, and it fits in memory, and you can do all your pandas stuff with it. And then we see what the pandas looks like. So there's a bunch more stuff that's going to be, that is in TextAdapter and will be in the free software release. It can deal with JSON stuff, and it, I didn't really show examples, but slicing does the stuff you'd expect with strides and negative indexing and all of that. You can do a couple other setup method calls about how missing data will be filled in, like if there's any, just an empty field in it, then just treat that as some certain value. You can do some introspection of these adapters to find out what was inferred and what's happening with them. But what I want to talk about in the remaining time, which is not as much as I hoped, so I'll go even faster, is 2 things, both some ideas for what to do next, like in this time scale of it becoming hopefully a community project, and then some general comments about open source and what is our, how does our private company, who really does have a commitment to open sourcing the software we do, at least as appropriate as possible, how do we deal with the strategy of doing it? So that just says what I just said. So one of the things that indexing that I just showed you is very limited. It's just, It's just an index into the various positions of the rows, which allows a fast seek into something that's much later, but it's not database style indexing where I actually, want to index on numbers or string values or things like that. And we could do that. I mean, we could add more kinds of indices that were more sophisticated. But on the other hand, it's sort of a trade-off. I mean, I'm not going to write something that's as good as one of the popular, I'm not going to rewrite Postgres or MySQL or SQLite to do everything it does based on CSV files. And if I tried to, it would be much worse than those implementations. And if it's a case where you really want all of that, you should probably just be using one of these things. But on the other hand, there's this, this in-between case. I said you're using the data a little bit, but not that repeatedly. So maybe we still want some better indexing. And I'm trying to decide, and I'll try to get to some questions, like how much better I can be. I mean, I think this first thing I say, like just looking at the strings and just, where is everywhere that the name Smith occurs in this data set? And, store that as a mapping from the particular key to all the different rows where it occurs, and, maybe one level of indirection, but that could be very fast to get something like that. So I think this equality indexing for a field is very straightforward. I could do that. Well, maybe I could do a little bit more of the pandas stuff. I mean, certainly I know how to compute, the lowercase of the string value of the thing. But then again, exactly which capabilities are there with transformations that might get indexed? And something that's like fully general. I mean, these are, in pandas or NumPy, you might write an expression of, of this sort very straightforwardly. But of course, what that's doing is it's doing a linear scan through the data that can actually fit in memory. Here, we're imagining that we're dealing with our gigabytes and gigabytes of data, and you can't fit it all in memory, and here you're just back to linear scan. I mean, yes, I could support that syntax, but just saying do a linear scan on the whole thing, and there's no speed up, which is what we're going for. So I'm interested in your thoughts about how far is feasible and worthwhile to do, given that if we go too far, just the advice should actually be don't use this, use database. This, mentions predicative indexing and stuff. I don't know the API that I would use for this additional indexing capability. I'll kind of skip through that. How many people in the room know Dask moderately well or have used that? Hardly anybody? I'm going to sort of skip over this because I want to talk about the open source thing a little bit. Dask is great, and it's open source. It's not proprietary. It's mainly developed by Continuum folks. At a bunch of these conferences, a bunch of our folks have given talks on it. But the idea of Dask is it does a number of things, but it's a distribution of tasks across either multiple cores or multiple machines in a cluster. And it can read in data in a blocked way. So you have this huge data set. You read it into thousands of different Pandas data frames, but the interface presented is unified, so it's as if you were operating on just one Pandas data frame. And it's really cool what it can do. And there's some overlap between what this does and what that does. So, but I think there's some differences too. For example, there's no concept of indexing in Dask. So I might describe these as higher level and lower level, but since Dask isn't that familiar, I won't go on about that. I do think there's a way, but again, you're not that familiar with Dask, of sort of making these things play together so we can take advantage of the indexing and the regex patterns and stuff like that that TextAdapter provides and make Dask behave better, faster. I'm going to skip over the Numba stuff. I think that we can probably accelerate some of the custom converter functions using Numba, which is a just-in-time compiler for Python code. I hope everybody's played with that. And again, free software, mostly produced by Continuum. Go use it. And we tried this a long time ago, a couple years ago, with a very earlier version of Numba and a very earlier version of IOPro. And I don't know if it actually ever worked, but it's not currently supported by current Numba. Because the idea is that you would need to convert a string to some sort of numeric thing, and Numba doesn't accelerate that now. And here's just a quick example, like I might use an Arabic numeral. Well, Python's int function knows how to deal with numerals of other types other than European numerals. But maybe we could do something like this. If we already took advantage of the converters to basic numeric types and then did some operation on them, and we could JIT that with Numba, and maybe that's a thing we do in the future if these converters are something that's very valuable to people. But basically I want to open it up, but let me go through the last couple things just really quickly. I don't get to decide this about the open sourcing stuff. I don't have a C in front of my title at Continuum. But I am very interested in the right strategy to do about this. And I think this is something that really is valuable to give back to the community as a company while not undercutting our ability to sell commercial software, which is a big part of our business. And I'm curious if other people have had a similar issue at their companies, but I think that probably the best approach to do this is something that, I call the ghost script model, but I'm old and people probably don't even use that software anymore, but the model that they had was the version that was released as free software was always a version behind the thing that the people who paid money could have. I know, right? Yeah. Okay. So maybe that's the approach we take. Maybe we release 1.9, the current version, as free, but then 2.0 has these cool things that people don't get without paying money for a certain number of months or until the next version or something. But maybe what does that mean if people contribute back code to the community project, and how do the licenses work? But maybe more importantly, how does the sense of really participating in the community and not exploiting it work? And that's a thing we have to think about. So that's basically it. I stop talking. I want at least a few minutes for people to ask things. Which hopefully somebody wants to do, since do you want a mic in the back? Or, well, the back was first, so we should go to him. That's you.
I was going to ask you about your first by the grade 5, but talking about the last point, what do you think about, instead of doing it that way, having clients pay to get access to support for remote issues rather than pay for extra features?
Personally, I think that probably works. I'm not sure that I'm not sure the people who are actually making the decision think that works. But in my mind, our big corporate or big, government customers, they don't want to go to GitHub and worry about compiling the Python code that's linked to some C code that has some Python components and making it work on their platform. They just want to type conda install. And, then it just looks at the license key. And yes, they could do it without paying money, but, they'd rather just pay money than have hassle. I'm not sure the support issue. Certainly, it could break and they want support and they want prompt address of those issues, and that's sort of the Red Hat model pretty much. But I actually think the support issue is less than just the convenience issue. But that's my take. I don't really know for sure. In the front?
If there's an index file, does that live with the file?
It lives, well, wherever you want to put it, but it lives probably on your local disk. And it's small.
And if you update the CSV file,
You have to regenerate the index. There's a method called create index, and you would have to call that again to actually do it if the CSV file changes. But I'm thinking that, for example, I gave the health insurance marketplace data. I don't have the ability to change that. I suppose I do when it's on my own local hard drive, but I really shouldn't. It's data that's produced by someone else, and I have to take as a immutable artifact. And that's the scenario that I think is most useful. But there's a method. You can always call create index again and regenerate the index, which of course is linear scan through the whole file and, you know, do the things you do to generate an index.
You talked about how far, question like how far to go with the index. I was curious, like in those first two examples where the problem pretty big. Like what's the overhead of adding the way the system? Like where does it, you know, it just generate a single like file behind the scenes? Like,
Yeah.
you know,
Well, okay, so I don't think you want to generate an SQLite file. I actually, oh, sorry, the question was, why not just generate an SQLite file rather than try to do my own funky indexing? And I actually, on my own local disk here, that's actually the show tables. I need to exit SQLite and show you. So I actually did that on my system, and I should have probably benchmarked it and see how it did. I'm sure SQLite's faster than any of this stuff. But think of the example where the data is published at the end of a URL or on a shared file system you don't control, or you know, S3 bucket or something like that. I mean, yes, you can download it, put it on your local system, generate the SQLite file, and access it much faster. But there are several steps involved in doing that. And if this is data that is sort of not transient, like in the sense it's going to change, but transient in the sense that you're only going to use it for a little while, maybe you don't want to do that. And maybe you don't want to allocate tens or hundreds of gigabytes of disk space on your local storage for this stuff that someone else is storing for you. On the other hand, if you're going to work with this data, if you're going to access this data thousands of times, do that.
My question was, how long does that take to generate these?
The current position-only index adds essentially nothing to the linear scan. So it's the same amount of time it takes to read the file in the first place. Maybe a 10% or something. I mean, it's a very small cost to do that. Now, if I did really complex indexing that did some sort of function, you know, abstraction, or, you know, made the lowercase version of everything, or all the different transformations, or you defined index based on some complex predicate, or conceivably that would take more time. I mean, I know I'm over time anyway, but. Oh, well, okay, can I take one more from the back, or am I cut off?
Well, maybe the next talk might explain it. But what about data that is not regularly structured, like you have an arbitrary form, every line, or every line has a different filter or indexing? I might have missed that. Did you cover that?
I didn't. And once we managed to get it publicly released, I welcome your contribution to adding that parser. No, I mean, I'm being a little tongue-in-cheek, but I'm really serious. That's part of the benefit. I think that's great. I, you know, dealt with data that has that. And, you know, maybe we'll do it in-house if I have time, basically. But as a community project, that becomes possible when somebody has a need for that sort of thing.
All right,
Well, thank you so much.
Everyone coming in.